Okay, we're going to talk a second about solving the questions in the radar quiz 0603. If you read the instruction, print out the instructions first and do all of your work offline so that you can fill in all the answers, and only after it's all done go back into the quiz and put the answers in. And then always print out a copy of what you put in so that if something goes wrong you don't have to redo a whole lot of work. We want to always read the instructions first for the quiz, and it says special instructions here. It says for questions 31 to 43, please refer to quiz 6, figure 1, and you can view this. Quiz 6, figure 1 is going to look like a radar. It's going to look like this. I printed it out. You can print it out. And then it also gives you a link to a black and white version, which is, I think, is a little bit easier to do your plotting on. So here is the black and white version right here. Now I don't want to give you the answers to the quiz, but I want to show you how to solve the quiz, the problems in the quiz. So what I've done here is recreated it, obviously without the accuracy of what's here, but it has some of the key points, and a radar display with targets B, C, and D on it. And what we're going to do is solve some of these problems. The first thing it wants to know is which target, B, C, or D, is a threat of possible collision with us. So up here we want to determine a threat. The next thing we want to do is figure out the direction of relative motion of each of the targets, the speed of relative motion of each of the targets, the closest point of approach, and the time at which the closest point of approach will occur. Now, because I'm working with just a display that I sloppily put together, I have no idea if any of my numbers are going to come out the same as what's needed when you actually sit down to solve this problem on this piece of paper using your navigation tools. So, first thing we want to do is look at the details around the display so that we can understand what we're dealing with. Up here, it tells us that this is in the head-up mode, and that means, excuse me, that means the top of the radar display is our bow. So we don't know yet which direction our boat is going. We don't know which direction the boat is pointed, but in any event, 00 up here at the top of this 360-degree circle is our bow. It says here range is 6 miles, 6 nautical miles. That's from here to here is 6 miles with 1 mile range rings. So we have 1, 2, 3, 4, 5, 6 miles of range rings. We also know down here in the fine print, our speed is 7 knots and our course is exactly true north. So we're going 000 is the top and our boat is going exactly to true north. And that's convenient for us because there's some additional mass step that we do not have to accomplish here. The other thing we need to know is that we have a plot clock that's 6 minutes. These dots are marked every 90 seconds. So what we mean by that, the plot clock 6 minutes, is that this point, the heavier blip on the radar screen is time now, and 6 minutes ago, target B was up here. So in 6 minutes, target B has gone from here to here. Target C from here to here, and target D from here to here. Now, one of these targets is a threat of possible collision. There are 4 vessels on this radar display. There's B, C, and D, but we are in the center. This is our radar display, and so our boat is right in here. So, first thing we need to know is that if nobody changes speed or direction, where would target B go? And all we're going to do here is we're going to extend this right down here, and this is where target B is going to go. Target C is going to go right down here, this direction, and target D is going to go, uh-oh, we have a potential collision because this target here is getting closer and closer and closer to us. So this target D is clearly, and that's the answer, target D is clearly a collision threat. Now that we solved that one simple problem, the next thing we need to do is figure out the direction of relative motion that's the direction of this vessel compared to us, the speed of the relative motion, and then we'll figure out CPA and TCPA. So let's figure out direction of relative motion of target B. Okay, so we drew this line in here, but what is its direction of motion relative to our direction? And remember, we're going here. So what we'll do is put our plotter on here, and we have to go over to the center. Oops, that won't quite do it. We'll put it over here. We have to go to the center of the display, which is here, and we read off the outside of the 360-degree compass here, and it'll be, that looks to me to be about 120 degrees. So our target B's direction of relative motion will be 1, 2, 0 relative. Okay, so what's its speed of relative motion? Well, in 6 minutes, we use our dividers here, in 6 minutes, target B has gone this far. So we can do a rough figure here. We say in 6 minutes, what we'll do, there's a distance scale. There's a distance scale right here. Let's just see what it is. I'll just measure it right here in 6 minutes. So this is going to be roughly about 1 nautical mile and 1.2 nautical mile. So it looks to me like target B is doing about 12 knots. So the speed, and that 12 knots is not relative, that's not their knot meter, that's relative to us. So it's a closure rate, as you will, a movement of a blip across our radar screen of about 12 knots. All right, next thing we need to know is the closest point of approach. Well, here we are, and here's the target. Here it's 1, 2, 3, 4, 5 and something 6 minutes ago. Here it's 4.8 miles away. Here it's 3 miles away. Here it's a little over 2 miles away, and then it gets farther and farther away as it goes by us. It's actually going to pass astern of us. But the point of its closest point of approach is where this line here is exactly perpendicular to us. So you need a 90-degree angle right here, and at this point right here is its closest point of approach. So you need to be exactly, this line has to be exactly perpendicular to us. That is CPA. So that's going to be 1, 2, 3 point, let's say closest point of approach. According to how I'm drawing it here, this has, who knows on the actual question. I'm just drawing it out here. So the closest point of approach, range ring, 3.2 knots. This is nautical miles. So that the closest this vessel will get to us is 3.2 miles away from us. And after this point, it gets farther and farther away. This one, the same deal. This one, when this is 90 degrees to us, which is right here, which is a little inside of 2 miles, that's its closest point of approach. But look at target D. Target D is coming right down our starboard bow. Our starboard side. It's coming right at us. All right, so back to target B. We want to know what time on our clock will target B be at closest point of approach. So in 6 minutes, it's gone from here to here. We'll just check that out here. 6 minutes. In another 6 minutes, it'll be here. And so there's 6 minutes from now. And that's about 3 more minutes, so 9 minutes from now. Our plot clock right now is at 0006. So that was 0. This is 6 minutes. Plus another 9 minutes is at 15 minutes on the plot clock is when this vessel will be at closest point of approach. And that's how we do it. So good luck.